So, hello and welcome to the DV Digest. My name is Brody, and this is your monthly digest of insight from design verification leaders. Now, today on the podcast, we have Will Keane. Will is currently the verification lead at AI chipset startup Fractile, and he's previously spent time at GraphCore and ARM. During this episode, Will talks to us about a couple of different things. He talks to us about why we should all be a bit more excited about open source tooling in hardware verification. He talks to us about some recent tools that have been released, and he also talks to us about his experience using these tools at Fractile. I think this is a super fascinating perspective. Will doesn't just talk about open source. He's using community-driven tools every single day, and today he's sharing his experience with us. I really hope you enjoy. So Will, welcome to the podcast. I appreciate you coming on.
Thank you for having me.
So what does the hardware world need to learn from the software world?
That's a great question. There's a lot, I think. I think the hardware world doesn't do a great job of recognizing shared problems that it would be better if we all tackled together with shared resources. If you think about the number of companies that have their own wiring script or their own linting flow, their own way to parse messages from different tool vendors. Everybody has to do this. It's sunk cost for everyone. And wouldn't it be better if a lot of that was out in the open and a shared problem? I think there is a lot of movement towards approaching things more like software, where in software, the base assumption is that any tool that you need to build your product is going to be free. So you don't expect to start a product and pay for a C++ compiler or an IDE to do your editing in or something to debug your program when it goes wrong. Whereas in the hardware world, by default, many companies expect to pay for those things. And there are companies that have made a good impression on the industry over many years by providing those tools. And that's all well and good, but I think the software way to handle that, to treat it all as a shared problem, is ultimately more efficient for everybody. I think that's the principal way, I would say. There are other things that I think software is a really interesting distinction between people who come from a software degree background and an electronic engineering background, where you tend to see this split in thinking about what code is. So for somebody who's done computer science, like, code is super important. Code is something that you shape and you tweak and you massage it and you optimize it for readability. You make sure that it's clear, that it's editable, it's maintainable, and there's a kind of art and a craft around that. Whereas I think the way EE tends to be taught is that code is more just a means to an end. It's something you have to do to get to an end product that you want. I think both things can be true at the same time, but I think the hardware tends to lean more towards that kind of pure pragmatics approach towards code. And that, I think, leads to hardware code bases being harder to maintain than the software code bases, because they're not approached with the same kind of love and care. So there's a few different topics there.
Do you think the reason that there's less open source in hardware is that sort of mindset that you're talking about, that from academics you're being taught that code isn't as important? Or where do you think that's coming from, that sort of divide in how you share tools and software?
Yeah, it's an excellent question. I mean, I can only present what I think is kind of my take on it. I think part of it is because whenever you do a venture in silicon or FPGA, it's something that's going to require you at some point to put a huge outlay of money into either a tape out or buying a bunch of FPGAs and then shipping them to customers. You're always having to deal with something physical. So at the end of your chain of actions, there's a physical product, and there's going to be a lot of risk associated with that physical product. So a software company can iterate quickly. They can do a release and they can say, here's version 0.1 of our product. And then a load of customers try it and they love parts of it, but they say, hey, actually this thing is really broken. You need to address X, Y, and Z. and they say, sure, no problem. And then a few weeks later, the X, Y, and Z can be addressed and made better. Whereas with hardware, there's always this kind of, I mean, FPGA, though, it is more like that, a lot more like that. But with ASIC particularly, you have this extremely long kind of route to having something. And therefore, I think it ends up being subjected a lot more to kind of project management type thinking, where it's all about minimizing the risk. And yeah, so on the open source side, I think this comes into play because there's the old expression among IT managers: no one ever got fired for choosing IBM. And then in the 90s, that got replaced with no one ever got fired for choosing Microsoft. I think in the hardware world, no one ever gets fired for choosing Synopsys or Siemens or Cadence. Like that is just a default choice. And so you're de-risking because everyone else has kind of trod this path before you. Whereas in software, you can just kind of mess around a lot more and just, hey, we used CMake on the last project, but why don't we try a different build system this project? Because why not? There's little risk to us. If it goes wrong, we can just fix it. So there's a bit more of a cavalier approach in software that I think we could do a bit more of with a bit more of in the hardware world.
Yeah, I mean, it sounds fun. Definitely sounds more fun. But what are the sort of benefits? What can open source be doing or has done that EDA can't?
Yeah, excellent question. I think, yeah, there's a number of different angles on this. There's the academic angle. So if everything's out in the open, then everybody is free to innovate, and all the academic research that's being done ends up being done based on real stuff that's already out there and used by people. So if you were to compare, say, someone doing a PhD in compiler theory, they are likely to be using some kind of state-of-the-art compiler that's out there, so some kind of LLVM kind of derived compiler, and that's just normal that everyone looks to see how well that big project can be pushed, and there's thousands of people working on that project around the world. So you end up with all the kind of effort funneling into a few kind of big projects that are all out in the open, and that inspires more open competition as well, which is a good thing. Competition is always a good thing for improvements. And yeah, so that openness, it kind of forms this virtuous cycle, a bit of a feedback loop. Whereas I think with the closed mentality, sure, you get improvements, you get competition between the big players, but you kind of get this downside where if someone wants to do some research into something, unless they partner directly with one of those companies, then their options are a little bit more limited. I think something that open source for silicon is really opening up is that research angle. So there's a tool I'm particularly excited about, which has been kind of doing the rounds quite recently, or gaining popularity, which is Slang, or SV Lang, which is effectively a free and open source compiler for System Verilog as a language. And it's crazy to me to think that, since the 70s or 80s, people haven't, well, they've tried, but people haven't gained traction by trying to sell anyone C compilers. So if you went into the market today and your strategy was to sell somebody a C compiler, it's not going to work out for you. People just use the open ones. You can actually still pay for a C compiler if you're super, like, if you care a huge amount about safety, or like functionally proven, kind of formally functionally proven lowering steps or whatever. You can actually go and pay someone for a compiler, but people don't, because the basic open source tools that you've got are pretty much the best thing out there. So that I find that a really interesting thing, that our side of the industry, the hardware side, has gone exactly the opposite way. That for many, many years, if you wanted something that could compile and then do something else with some System Verilog, the vast majority of those tools were locked away behind having to pay.
What is the compiler? Why are you so excited about it?
Yeah, so Slang is a open source compiler for System Verilog. So it's fully compliant to the LRM, or pretty much 99% of the way there. So you can it's effectively a front end for any system Verilog code. And the difference between it and another open source tool that takes and parses and does something with Verilog or system Verilog is that it produces an intermediate representation. So in compiler land, you have some kind of programming language, and then it's all about lowering that towards whatever your final target format is, which in the majority of cases will be assembly code running on a CPU somewhere, or for GPU code, down to GPU assembly. Sorry, you get what I mean, like down to a binary that comes from the assembly. But along the way, the kind of the normal thing to do now is that you produce various different intermediate representation levels, and then each lowering is getting you closer to where you want to be and performing optimizations, like making the thing better. In the hardware world, you don't have a compiler that does that generally until Slang. You have different tools. So you have Verilator, whose job is open source tool, brilliant tool. I love it. We use it a lot at Fractile. But its job is to parse the system Verilog and then convert that to some C++, and then that's it. It's job done. Or Icarus Verilog, again, great tool, takes the Verilog and interprets it so that you can run it. There are other tools out there that each have their own kind of job that they do with the system Verilog. The exciting thing about Slang is that it doesn't just produce one output for one purpose. It produces an intermediate representation of what that system Verilog was trying to do. And that means that there are any number of tools that could consume that representation to achieve what they want to do. So whether that's to do a functional simulation, or whether to do some kind of physical flow to turn it into a netlist, or whatever it may be. And it's really I think it's the first time that I feel the industry has had some kind of reference compiler we could all get behind. And another really exciting thing about it is that it's already inspiring a bit of competition. So at ORConf, where I was a few weeks ago, there was a presentation about DynoIR, which is a kind of competing intermediate representation, which is not associated with the MLIR project, where they've seen what Slang are doing and they're like, hey, that's a cool idea, but we think we can push it further in the hardware world. But by doing something a little bit different. So taking the same compiler theory, but doing something a bit different. And again, I think what this could lead to, and why I'm excited about it, is a more kind of general set of tools which can use one thing or a few things as possible front ends. So they take the code and then you can do whatever you want with that code on the back end. And I think so for us, we're already using Slang. The fact that it can produce abstract syntax tree and IR, we're using it already to enforce some custom rules on the Verilog that we write and simulate and synthesize, so that we know before it goes to those other tools that have their own particular opinions that we've eliminated certain bad behaviors that we don't want. So there's a huge amount of kind of power that puts in the hand of the user. So that's something I'm very excited about. I think it could lead to a lot of very cool tools.
What's the benefit that you're seeing from using things like Verilator, CocoaTB? Why are you doing it? On a kind of
Good question.
Day to day, working, building your test benches, etc.
Yeah, well, I did say before, no one gets fired for choosing IBM. So I'm kind of putting my reputation on the line by going heavily in on open source. So CocoaTB is brilliant because it works with the three major vendor simulators and open source simulators like Verilator and Icarus. So by choosing to write your test benches in CocoaTB, you're not taking too big a risk in terms of product development. What you're valuing more than anything, I think, with CocoaTB is developer time. You get to code in Python, which is the world's most popular programming language. And it's there as the most popular for a reason. It's because it's extremely easy to do a large number of things that you want to do just by importing some library someone's already written and using their stuff. And it's pretty interoperable with other languages. That's not the easiest, but it's much, much easier than System Verilog. So it enables us to write test benches in a way that we can take the work that's been done by our software colleagues and import it directly into a test bench context and use it there. So whether that's a model of the system or a means of generating stimulus or test patterns for a hardware system, we can hook directly into it. So it's kind of moving more towards a software mentality of how would we build a system to create test benches that can do whatever we need. CocoaDB becomes quite a natural choice, and it allows us to use open source simulators and proprietary simulators that we don't have to, it's not an exclusive thing. We can choose both. The other side of it, on choosing an open source simulator like Verilator, so all our kind of test bench code and our RTL, the first thing it will see is Verilator. And the reason we do that is we want to get it into CI, and we want to run our CI tests by default under the same kind of the same framework that the software runs everything. So we all work together in one big repository, and we use Bazel as a build system, and that enables us to run all the tests all the time on every CI. So we the Bazel CI is very smart in that it has a cache, and therefore it doesn't rerun any tests that don't need to rerun when a particular PR goes up. But the fact that we use an open source simulator like Verilator means that our license costs for CI stay at zero. We don't need to worry about how many changes are going through per day. We know that those changes will be tested, not 100% thoroughly, but pretty well, just by chucking all the tests through the open source simulator. And Verilator is reasonably strict on compilation and stuff like that as well. It's not perfect, but Slang, so we're using Slang for lint now as well. That's stricter typically than Verilator. So we get all these lint kind of base flows for free effectively by building and running the RTL in them. So we've been able to get off the ground as a startup. We've got a fair amount of compute in place now, but before we had that compute farm in place, we could all get by just working and running on our laptops. We have a MacBook each. It's a fantastic, powerful machine, great battery life as well. So you can actually run quite a lot of sims just locally on your MacBook. And that's just really enabled us to get up and get going very quickly without having to be held back by how many licenses do we have, how much compute can we assign to each person. So it's enabled us to move pretty quickly, I'd say, is the main set of benefits that we've seen so far. And as I said before, just really, really values the developer's productivity and time.
Do you think that this sort of way of working using open source tools is applicable for larger companies at all? Or do you think it's mainly in the realm of startups and scale ups, and then you're going to eventually have to move over to Cadence, Synopsys, Siemens? I have to by law say all three. But yeah, do you think is this just a startup sort of fad?
Yeah, great question. I think being a startup gives you a certain degree of freedom that you don't have as a big company. If you're a big company and you're already using a certain way of doing things, it's just much stickier. It's just much harder to change. If you know you've taped out a successful chip using Cadence, Siemens, Synopsys, then you know that doing it again is likely to yield similarly good results. So that's one side of it. I think that as a big company, there is still a place for this stuff. It's just a lot harder to kind of justify the technical cost of bringing it all up and switching over. I think as a startup, we have to ask ourselves the question, how do we do the most that we possibly can with the resources available to us now? And that the answer to that question might be different for a larger company. I do know that there are large companies out there that do still lean into these open source tools. I think they can get you a long way. There are, even for us, there are tasks that we can't accomplish by using open source tools. So we do of course use proprietary EDA licenses, and I don't want to be misinterpreted as saying I'm anti paying for something. I think when someone has a product that works, that does what you need it to do, sometimes exactly the right thing to do is to just pay for that product. And there are a number of tasks along the way from a spec to RTL to some GDS2 that you can send off to the fab. that you have to do those tasks with proprietary software at the moment. I think there's a big kind of exciting movement in the open source silicon community, though, to plugging a lot of those gaps and wanting to see the ability to go from RTL to GDS2. So as an example, I recently got to complete a tiny tape out, courtesy of Matt Van and Tiny Tape Out team, which was great fun. And that pretty much entirely uses an open stack to get you from the RTL that you've written all the way down to some GDS2, which then goes to a Foundry, and that's based on an open source PDK as well. So it's possible. Whether all of that catches up and at some point displaces the big EDA vendors, I don't think it kind of even needs to, really. I think it actually benefits the big EDA vendors that it exists. The first big reason why is the skills gap. So we have a huge skills gap in the electronics industry more broadly. We have way more jobs than we have people who can do those jobs. And that's being felt by companies of all sizes. It doesn't matter whether you're a startup or whether you're a massive company trying to kind of add things to your product roadmap. It's hard to recruit, and it's hard to get enough people, good people in and doing the jobs you need to. And having completely open tools for people to mess about with, and this is how a lot of great technology is born. It's just by hobbyists messing around with tools. I think it's in everyone's benefit and interest to have that tooling out there so that it can be used by some crazy guy on the internet who's got some brilliant idea of how they could improve a hardware tooling flow, and that person may a couple of years later end up working for a big EDA company and massively improving their flow. And I think it's quite a virtuous kind of cycle. I think at ORConf, Andrew Kang, who led the Open Road project for this completely open source flow from RTL all the way through to GDS2, he was asked a question along the lines of whether this stuff could eventually replace the big vendors, and he seemed pretty emphatic that the answer is no, but that it's still extremely worthwhile and worth the vendors being interested in as well. That there doesn't need to be this kind of competition for existence. That it can all be mutually beneficial. That open tool chains exist.
That's really interesting. Yeah. I mean, I've always kind of seen it as a I don't know, competition of some kind, I guess. But yeah, okay. I mean, you mentioned how some crazy guy can come up with a tool that's brilliant, and everyone loves it. The issue that I see is around sort of tool support, and having a group of people that are accountable to your tool working well. What's your experience with open source and support? Is the community enough? Is the community always enough? What's your general experience there?
Yeah, it's an excellent question. It's a complicated answer. So yeah, to compare with the traditional experience, if you go to a vendor and you pay for a tool, you expect the tool to work. If the tool doesn't work, it's part of your license agreement fee that you get support for the tool. And again, when we go back to that question of risk, that's an extremely helpful thing as you're on the road from RTL to GDS2 to offset that risk by having a third party involved who's been through many successful tape outs. And that makes a lot of sense. It's a compelling argument. I think with open source tools and the security of those tools, or the efficacy of those tools, I think you only have to look into the software world at some of the biggest examples. So Linux, for example, the Linux kernel is open source. It's the most popular operating system in the world in terms of the number of computers that use the Linux kernel. And it's where the vast majority of all development of all software takes place as an operating system. And it doesn't lose anything in security by being open source. It actually gains, because suddenly you have all the scrutiny you need from the community. have a huge number of people now who are very invested in this operating system being secure and having correct principles to operate from. And in a way, it's similar with the open source hardware tooling systems that are out there. The more people who begin to rely on them, the more people who care that they are correct. And as I mentioned before, the more then academic research funding can go into improving them and increasing that confidence. And if you look in the area of security more generally, there's this principle that you learn at university where security by obfuscation is never as secure as security by correctness. So if you have, if you hide your security algorithm and everything is lost as soon as that algorithm is revealed to everybody, that's a lot less secure than a system where the algorithm is already known to everybody. Everybody knows its potential vulnerabilities, and people can use it freely, knowing that it's been checked by many other people out there. So things that we use all the time, like two-factor authentication or public-private key pair, that kind of technology is the vast majority of stuff around that is open sourced, and that doesn't affect anything negatively. In fact, it's positive. I'm not saying that the open source hardware ecosystem is in as mature a place as Linux or OpenSSL or something like that is not, but I don't think necessarily that being open detracts from that. But I completely see the argument for de-risking by using a silicon-proven partner. And then what you said about support, sorry, it's a long answer to your question, but there is now an increasing, so you'll have heard of Red Hat Enterprise Linux, right? So Red Hat, they take the Linux kernel, they bundle a load of software together with that kernel that they are very confident will all work correctly together. They provide package management and they provide support services, and the operating system is free. Off you go. You can install the operating system, but if you want support, you go to them, you pay. It's that works as a kind of as a business model, and that's often the case with open source software and its business model, that there's a kind of support cost to a particular company that's the vehicle for that tool. For a lot of the open source silicon tools out there, there isn't necessarily a specific company that is the one vehicle for that tool. That is changing a little bit. So the Open Road project is going to be owned by a company called Precision, I believe. That was discussed at ORConf as well. So they're going to be the kind of commercial vehicle that drives that open source tooling forwards. But then more recently, you've got companies like Ant Micro as well, which is a superb company, I think. And their philosophy is that they take on contracting work for open source tools, and Verilator is a particular specialty of theirs. They've contributed a huge amount back to Verilator, especially in the last few years, and they're on this kind of quite focused project to get all the features of UVM working under Verilator, for example, and they've been very effective at that. And they also operate now a kind of support-based kind of service. And there are also independent contractors out there who are serial contributors, and you can look through their GitHub history and see how well they've contributed to projects over the years. And you can enlist their services and say, okay, I'm having this specific issue with this tool. Can you come? We'll get all the legal stuff in place, sign an NDA, the same as you would with a third party EDA company. So it's kind of you can kind of get some level of similar support. It's not identical, admittedly, but it's not impossible. It's not out of reach as it once used to be, I think.
You mentioned your visit to ORConf, and I actually watched your talk. And at the end of the talk, you had two questions about sort of related tools that you hadn't heard of at all. How do we improve sort of visibility of various different tools so that more people are kind of able to benefit from them?
Yeah, great question. OurConf was a great way to do that for me. So in presenting my own tool, I learned an awful lot, not just from the questions from my own talk, but more generally from everyone at the conference who was there speaking. You get a huge kind of exposure to a lot of tools that are not necessarily in your immediate kind of area of expertise. So I learned about a tool called GDS Factory, which is an analog, quantum, and optics kind of design package tool, completely open source. And again, the company behind that operates a freemium model. And I would never have known about that tool at all had I not attended that conference. I think the FOSSI Foundation did a brilliant job of pushing the kind of the agenda forwards of open source tools and open source silicon. And there are other organizations out there as well that are keen to do that. So I think attending conferences is a great way, and keeping up to date with news. I mean, as cringy as it is, like LinkedIn is actually quite a good source of news for projects that people are dropping. The Discord that you've set up, I think people post stuff on there. There's other things out there as well. Like FOSSI have a kind of chat kind of thing that you can join and hear what people are doing and saying. There's a Tiny Tape Out Discord. There's a bunch of stuff out there. Admittedly, it's not the most accessible thing in the world. If you were just getting into it from nothing, it might be a bit tricky to kind of start out. There are other people like Andreas Olofsson, for example. He maintains a repository of awesome open source silicon tools. There's a lot of repositories like that on GitHub where it's awesome X tools, whatever the topic is. And he's got a pretty good repo there of just a whole host of different tools that you might find useful. So yeah, I agree with you. There is a bit of a discovery problem, and on some occasions people doing exactly the same work twice, and then meeting up afterwards. But I think typically it's good natured enough that no one's kind of like too precious about it. I think like people just want to see the work moving things forwards. There was a guy who gave a talk on Chisel, who's been one of the key contributors for the last 12 years or so. And he commented on other competing high-level HDL tools like Chisel, that he's delighted that there's a lot of competition. And he thinks that that's exactly the kind of thing you want to do, is inspire competition with your tools. So yeah, real problem. Not 100% sure how to solve it. Hopefully, as things gain more traction, people will be more interested in attending conferences, in posting their work publicly, in just announcing that this thing is there, and maybe someone would find it useful,
Yeah. I mean, I have a feeling that correct me if I'm wrong, but I have a feeling there's probably an almost two-tier exposure to information. You have the sort of LinkedIn people, so people like you and me, like on LinkedIn, engage with people generally. But then I imagine you have you could probably even say the majority of people that aren't scrolling through LinkedIn, aren't really engaged in the ecosystem. How do you reach them? Do you know what I mean? Like, is that just something that you have to do at work and you have to be pushing at work, or I don't know. I have no idea.
Yeah, I don't have the answer, I think. I first, for what it's worth, from my point of view, I first came across open source silicon tools through work when I worked for GraphCore, and they were pretty heavy users of Verilator there, and they had their own in-house kind of custom verification flow using C++ and Python. And that was the first place that I worked where that kind of thing was not taken for granted by any means, but just it was possible. It was clearly there in use, real, and in use for production as well. Chips taped out on the back of what they'd done. And that, for me, as a kind of younger engineer, that was very eye-opening that a real company had actually used these tools to produce something. So possibly it does just come from, you're a graduate, you get your first job, and at some point during that job, you gain a little bit of exposure to someone using one of these tools, and you kind of think, that's actually pretty cool. I do think it will grow. I think it just will grow over time, the kind of enthusiasm and exposure to these things. That what someone said to me once, many years ago when I worked for ARM, actually, there's a bit of wisdom was dropped on me by someone. I was trying to kind of push an internal tool that we'd written and kind of get people to be excited about it. And the guy said to me that if a piece of technology or something to help someone do their daily work is good enough, all you have to do is show them, and they should want it. That it should be as simple as that. It should be, you show them this is great, and that immediately, yeah, how do I get it? How do I install it? That should be the first question. There was even again, I keep going on about ORConf, but there was a talk about this at ORConf. Someone mentioned that the best projects in terms of getting people on board using them, when you land on their website, they assume you have about a 1 minute attention span. So I give a great open source silicon tool to give an example is Surfer. When you land on Surfer's web page, it's an open source waveform viewer. When you land on the web page, you think you've got a screenshot in front of you. It's actually not a screenshot. It is the real tool running live in your browser right now. And so the first exposure you have to it is, hey, it's there in my browser on the link I just clicked. Oh, I can drag signals around. Cool, I can zoom in and out. And oh, this is great. Yeah, I'd like to download this and use it. So I think maybe that's a really helpful way that you can just lower the barrier to entry. You can just put something out there where the very first splash page someone sees is just, right, to get this, pip install package name. Here's a simple example to copy and paste. It will just work, I guarantee you. And if you can grab someone's attention and then their imagination starts whirring of, oh, cool, how can I actually use this then in my day-to-day work? What would be a first thing that I could solve with this cool little tool? Does that make sense?
It makes tons of sense. And I was going to go on to what engineers can do to sort of convince their managers to get involved more in open source tools and try out different tools that you're talking about. But I think that probably answers it in some way. Show them the benefits. Let them play with the tool. Yeah, so it does make a lot of sense for sure. I mean, we're kind of running out of time here, Will. So last question from me. What's going on at Fractile at the moment? Why is it an exciting place to be, and why should a verification engineer come and join you guys?
Yeah, thank you. Yeah, a little shout out at the end. Yeah, so we're doing exciting stuff. We're building really exciting machines to accelerate AI inference. We're doing something we think is pretty unique and different to what else we see out there. We're doing that in a different and unique way as well. We're building on the back of a very strong set of shared infrastructure between the software and the hardware team. So we work together in a monorepo environment. We use Bazel as a build system across software and hardware. If you're a verification engineer, you spend your days writing Python, talking to engineers who write the C++ models, sometimes writing some C++, sometimes writing some infrastructure code. We try and multiply up the productivity of every engineer by the tools that we write internally. We're very, very pro open source, both in terms of taking and opening. So that's an exciting thing to do as part of your day job. Yeah, and in terms of what we're pushing towards, it's not just kind of tooling for the sake of fun tooling. It's pushing towards, extremely robust, correct RTL as early as you possibly can for a given piece of design, at least in the verification world. And we're trying to maximize everybody's productivity. And we really try and avoid the not invented here kind of mentality where you say, I just don't want to use that because it's not familiar to me. We try and challenge ourselves. And if something new comes up and it looks like it's better than what we've got at the moment, we actively seek to try it out and see whether we can speed ourselves up in some way by including it. So yeah, if you are excited about doing things in a slightly non-standard way, but potentially gaining huge productivity improvements and kind of having a passion for correctness that goes beyond just your day job and goes into some serious tinkering with tools, then that's the kind of role that you get to do day to day as a verification person at Fractile. And I think more generally as well, we're trying to do innovative things across the board. So in the architecture of the product, in how it's developed in software, how we build together as a team, And I think that creates quite an exciting culture across the board. So I'm loving it. It's a great place to work. So yeah, we are hiring. So do do check out our website.
Fantastic. Well, I really appreciate you coming on. It was really, really interesting. And yeah, I'll see you later.
Great. Thanks very much, Brody.